Hello everyone, here's Mr. Kablan with a second lesson here for chapter 8 that we dealing strictly with perimeter and area of what are called composite figures. And you're going to see in today's lesson that we're just going to revisit what perimeter and area is and how we can use it to find the perimeter and area of two or more different shapes here. Now before we begin, if you go in your package there, I want you to look for the formula sheet, which looks something like this. And we'll be using this formula sheet for the remainder of the chapter here. And I'm just do a quick glance here just to show you which formulas we'll be referring to in today's lesson. So if you look on the left set of formulas there, the ones that deal with perimeter and area, okay, you're going to see those are the formulas that we'll be referring to for some of the examples in today's lesson. So just keep that handy. All right, so let's get to it over here and talk about what we're going to cover when we're looking at perimeter and area of composite shapes or figures. So as I said before, today we're just going to revisit something that you were introduced to, but we're just going to take it up a notch and see how we can actually use it when we're dealing with two or more different shapes here. So basically, all the figures that we're going to look at is we're going to look at a shape that consists of two or more figures. And what we have to figure out in each case here is after we find out the area or perimeter, we need to figure out whether we add or subtract those values from each other. So again, when you're looking at these questions, always take a look at what the diagram looks like and then from there approach it using that. Okay, and when we're dealing with perimeter, quite often people will go straight to the formula sheet and start putting the numbers in into a formula here. But what's important about perimeter, and you're going to see it for the examples we're going to see today, is that perimeter always refers to the distance on the outside of the shapes we'll be looking at in today's lesson. So when you're looking at perimeter, just factor that in, that the easiest way to do it is to look at the side lengths that are given to us. And if there are any missing, we're going to solve for them. And then whatever those measurements are, just add them together. So you don't necessarily have to jump to a formula every time you're dealing with perimeters. So let's take a look at how to do this here. And as you can see in this question here, we want to calculate the area and perimeter of this shape that you see on the screen. Now, as you can see here, when we're dealing with the shapes, first identify what shapes you have. As you can see, we have a right angle triangle, we have a rectangle, and we have a semi or half circle here. So what we need to do here is for all the cases, break it down into those parts, and then from there figure out whether we have to add or subtract the whatever we're solving for. So we'll start off with area first. And the way we're going to do that is we're going to find the area of each shape I just mentioned, and then from there figure out whether we add or subtract them. Okay, so we're going to calculate the area of each shape first, starting off with the triangle. So if you take a look at the triangle, we have base times height divided by 2. Now the base, as you can see, is the entire bottom there, which is 12. And the height here, okay, believe it or not, is actually the same thing as the diameter of this circle. So what we would have here would be 12 times 16 for the top part. Okay, we're going to multiply those two numbers and then divide it by 2, and that gives us 96 square centimeters. So that's going to be the triangle there. Okay, next one here is going to be the rectangle, which most of you probably know already as length times width. Okay, and what we have here will be a length of 25 and a width of 16. Okay, and that's going to give us 400 square centimeters. Now, for the circle there, if you take a look at what we have here is a semicircle or half circle. So if you take a look at your formula sheet, you'll probably notice you have the formula for the area of a circle, which is going to be pi r squared. However, since we're dealing only with a half of a circle, okay, we're going to take the formula and divide it by 2 or just put it over 2. Okay, so that's our first step, is just to modify the formula for this question. Now, remember that with a circle, we have to find what's called the radius. And as I said earlier, just a few seconds ago, that 16 is the total distance across from the circle. Okay, remember what a radius is. It's the distance from the center of the circle, okay, to the end of it. So what we have to do for this is that this 16 here, okay, is actually a diameter. So we have to cut it in half just by taking that number and dividing it by 2. So when we take the 16 and dividing that by 2, that's going to give us a radius of 8. So you can see we're now going to put that 8 in for the r and then solve accordingly. So what we would have here would be pi 8 squared on the top divided by 2, which is going to give us 100.48 centimeters squared. Okay. Now, just by now we have to figure out whether we need to add or subtract these shapes. Now, you notice that these three shapes, okay, you're just grouping them together. So to find the total area, we're just going to add them all up accordingly. So for the total area here, okay, we're just going to add up those three numbers I have in the boxes. So the total area of the shape here is going to be 596.48 square centimeters. All right. Okay, so now that we found the area, let's take a look at perimeter. Now, perimeter, just a double check here. Remember that what we have to do with perimeter is understand that what perimeter is the distance around the object. Okay, so if you take a look at what we have here, okay, we need to find up all the lengths or distances first and then add them all up. Now, if you take a quick glance here, we do have a couple of measurements that are missing. In fact, there actually is a measurement that we actually have to calculate before we actually do all this. And if you take a look at the triangle, okay, notice what we have there. What's missing is that side there, which we do need to use the Pythagorean theorem for. So that's our very first step to make sure that we have all the measurements that we need. Okay, so we're going to use the Pythagorean theorem to solve for the length of the hypotenuse, and that will give us one of the measurements there, or one of the unknown measurements. So using Pythagorean theorem here, okay, we're solving with the hypotenuse, so that's going to be our C. Okay, so our 12 here, we can make our A, and our B here will be the 16, which is the vertical distance of the triangle there. So when we put all that together, we get 12 squared plus 16 squared. We're going to simplify it from there. So 12 squared is 144, 16 squared is 256, and that gives me 400. And the final step here, we're going to take the square root of both sides, and this will give me a hypotenuse here of 20 centimeters. All right, so there's another measurement there. Another gap you can fill in over here as well is the bottom part of the rectangle there. Okay, now as you can see, I've highlighted in red exactly what we need to calculate there. Now, before I look at the red, you notice there's those two thin or faint dotted lines inside. For perimeter, you do not include that because that is not it's not the outer parts of the shape. So with perimeter, you're only looking at the distances or the measurements that make up the outside of the shape here. Okay, and that's why I highlighted it in red. So what else we have to do here again is we now need to find the distance in the circular part. Now, the distance around a circle actually has a special name, which is circumference. And what we have to do here is to find the circumference of that part of the circle. Now, since it's only half a circle, we need to take the formula for it and divide it by 2. Okay, so that's what we have to do in our first step before we actually look at the calculations. Now, we're going to use the radius here because it's what we solved for in the previous question. So we're going to put the 8 in for the r. Okay, and when we simplify that, that gives me 25.12 centimeters for the circular part. Okay, now just to double check here, if you're looking at the red outline, the only missing measurement that we have now is just the bottom part of the rectangle here, which is 25 centimeters. So to put all this together here for the perimeter, we're now going to add all those up. Okay, so starting off with the 12, which was given to us, the 20, which was the hypotenuse, which we solved for, the 2 25s here, okay, come from the top and the bottom of the rectangle, and the 25.12 comes from the circumference of a half circle. And again, just as a reminder, okay, you do not include, okay, the 2 lines that are inside because that is not part of the outside of the shape here. For perimeter, you're only looking at the distance around. All right, so when we find the perimeter for that, that's going to be a total of 107.12 centimeters. Now, before I move on to the next example, okay, if you remember, if you check the last example, and I'm just going to scroll through it real quickly. When we're looking at area here, okay, notice the final measurements, okay, even in the in-between steps was all the units and it was squared. So anything dealing with area is always going to be square units. Perimeter, on the other hand, okay, is a measurement of total distance or total length. So that's why our answer for this one over here, for this question, it was all still in centimeters. Okay, so just remember that when you're doing the measurements, that the units are equally important as the numerical answer. So again, perimeter is a measurement of the total distance, so that's why the units remain the same as the measurements in the question. All right, so let's take a look at another example. And this time, we're going to be dealing with 2 shapes over here. Now you can see for this one, just compared to the other one over here, what we have here is, again, we have a rectangle and a semicircle. But you notice in this example here, the semicircle looks out, it's been cut out of the rectangle. So that's going to be something important to understand because the approach to this is different from the one that we just did. So to calculate the area, what we need to do here is to calculate the area of the two shapes first, okay? And then from there, after we find the area of the two shapes, subtract them from each other. Okay, so once we figure all that out, that will give us the total area here. Okay, so starting off with the area of the rectangle first, okay, we have 5.8 times 8.2, and that's going to give me a total of 47.56 square centimeters. Again, note the units. Okay, and again, we're going to find the area of the half circle there. So there's the modified formula. Now remember that the R here is a radius, and at the top part over here, okay, what we have there is a diameter of 5.8. So before we actually put it into the formula for the area of a half circle, okay, we have to take the diameter first, divide it by 2, and that'll give us 2.9. Okay, and that 2.9 is going to go in for the radius. All right. So now that we have the two areas over here, as I said before, what you're doing here is now you're taking that half circle and then you're removing it. So if there's in any diagrams that look like something has been removed from another shape over here, then you have to subtract the areas. Okay, and by doing that, that will give us a total area of 34.36 square centimeters. Now, this area over here, again, is the area of the shape that we started off with in the question. So, but we still have to calculate the two areas over here, but the main thing you have to understand here is why we have to subtract the areas. All right, so for the perimeter here, we're going to approach it the exact same way. Okay, so first things first, we need to find the circumference of the half circle, just like we did in the previous question. So we have a radius of 2.9, so we're going to put that in the formula. And this will give us now a distance of 9.11. Okay. Now remember that when you're dealing with perimeter, you're looking at the total distance around. So that 9.11 is part of the half circle. We have a 5.8 and an 8.2. So the only measurement that we're missing here is the side across from the 8.2, which is, well, 8.2 again. So for the total perimeter of this, we just have to add those four numbers that I've put in the diagram there. So the total perimeter of that object is going to be 31.31 centimeters. All right, so that wraps up perimeter and area of composite figures there. So I will see you in the next lesson.